All right, students, we're going to go over writing equations of circles. This may be the first time you've seen it, this worksheet, or I might have gone in the reverse order. You've already done one, and this is now the second time for more practice. All right, so are we on the front page here? Right here. Here's front page. Writing equations of circles. So first off, we need to know the standard form of a circle is right here. Okay, H comma K is the center, and R equals the radius. Okay, so notice it's x minus h. So minus, another word for minus is opposite. Y minus k, another word for minus is opposite. And notice this is r squared. So if they gave it to me in standard form to find the center, I do the opposite, and then the square root. Square root of r squared gives me r. Okay, so if they're ever given to you in standard form, I want to hear those three words: opposite, square root. It's never same. On the DCAS, if it's multiple choice, they'll put the same there to see if you know. It's never, nothing we do is same. Opposite. Okay, and then square root. So we go ahead and look these first two. The center is at the origin, so that's nice and easy. It'd be just x minus 0, which is just x, plus x squared plus y squared, and I just count out the radius 2, so 2 squared would be 4. Okay, that's simple. So let's look at one. You actually have to do a little thinking. So the center is 1, 1. So again, when I write it, it's going to be x minus 1 because it's the opposite. X minus 1 quantity squared, y minus 1 quantity squared, and what's the radius? Out from the center out to one of the endpoints, 1. And then 1 squared is 1. So there's my equation right there. All right, let's go ahead and go down to here. Now, without it being graphed, they just give you the information, then once you write it in the standard form equation of a circle. So again, it's opposite, so that's why it's x minus 4 quantity squared plus y, and then opposite minus 7 is plus 7 quantity squared, and then r squared, 13 squared is 169. All right, now they give you the center and a point on the circle. So you have to use the Pythagorean theorem or distance formula to solve for the r, and then of course you're going to square it to write the equation for r squared. So 0, 0 is the center. I go out 3, down 4. So 3 and 4, and that's a 3, 4, 5 Pythagorean triple. If you don't have those memorized, then you use Pythagorean theorem. You get 5 right there. That's r. But remember, we want r squared in our equation. So 5 squared is 25. That's why you see 25 over here. And the center was at 0, 0, such as x squared plus y squared. Okay, backside now. Now there's a little more work involved because it's not right at the origin. You have to use the distance formula. When I have bigger numbers like this, it's probably better to just use the distance formula. So I've written out the distance formula here. Okay, remember, addition is commutative. So I could have put the x sub 2 minus x sub 1 quantity squared first and had those switch. It doesn't matter because I'm adding them. Okay, don't forget, I'm squaring both these subtractions. So when I square a number, I always end up with a positive. So you better have positive numbers on both of those underneath there. Never a negative. All right, so subtract my x's. How far is it from negative 43 on a number line to negative 34? That distance is 9. That's why you see 9 here. And I square it. How far is it from 5 to 17? That's a distance of 12. That's why you see 12 squared right here. And so 81 plus 144 is 225. The square root of 225 is 15. So r is 15. So again, to write, I have my center given to me, opposite, x plus 43 squared and y minus 5 squared, 20 squared, because those are the opposite, and then remember it's r squared, r is 15, so I square it and I get 225. Okay, remember this is r squared right there, 225, not r. All right, determine the diameter of the circle with the given equation, okay? So again, diameter, remember, equals 2 times r. So I find the r. Remember, this 100 is the r squared. So that's why you see me take the square root of that to get r equals 10. And I just double the radius to get the diameter. So 2 times 10 is 20. That's why the answer is 20. Okay, nice and easy right there. All right, graph the equation now. Again, so we have that. The origin is the center. and then I just go square root of 64 for my radius, so I get 8 equals the radius. And I go out 8, 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8, and draw my circle the best I can through there. Okay. And last example down here. Okay, let me erase this so you can see it better. I had this on one of your review problems for the semester exam. Okay. And you'd see it on the DCAS. I'll put one on again somewhere on the test itself because most of you missed it on that semester exam in order to review. If it was on the semester exam, it was on the review at least, and most of you missed that. Okay, it's asking if this point is on the circle. Okay, in this case, they give me the equation. I need to plug in the x coordinate into the x, the y coordinate into the y, and check to see if that statement is true. So 13 minus 3 is 10 squared is 100. Plus 8 minus 8 is 0, squared is 0. Does that equal 100? Yes, it does. So that is on the circle. Okay, if they gave you the graph, I need to write the equation of the circle, or if they gave it to me, and then plug it in here. Do not look at the graph and see if it fits. Identify the equation, the graph first, and then plug it into the equation. The one you guys missed on the review for the semester exam, it looked like it went through a radius of 3, but it was just over. It's like 3.1 or something like this. So you can't trust the pictures. You need to go by the equation itself and check it. Okay, and that will end this right here.